Good afternoon, everyone. Welcome to the Construct Innovate webinar series on sustainability planning and construction. My name is Jamie Eoghan, and I'm co-director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. So we're on the last webinar in the webinar series on sustainability planning and construction. The focus this week is on advancing sustainable infrastructure. So this is a 7-part series. As I said, it's the last week in the 7-part series. But we kept really good speakers for the very end. So we're delighted to have 3 eminent speakers today. So we've Gus McCarthy, who's former managing director of MKO. So he's in MKO for, I think, about 25 years at the forefront of planning in Ireland. So he's going to give us a practitioner's perspective on advancing sustainable infrastructure. We have Dr. Maryann Harris, who's environmental planning manager in the Department of Housing, Local Government and Heritage. She's got a lot of experience around environmental assessment, and she's going to speak about how to make communities more climate resilient and biodiverse rich. And then we've got Professor Eoghan Clifford, who's Professor of Engineering and Head of the Discipline of Civil Engineering at the University of Galway. And he's going to concentrate on wastewater treatment systems and how we advance sustainable infrastructure in that area. So we'll have our 3 presentations, each about 15 minutes each. And that'll be followed by question and answers at the very end. So if you have any questions for any of our 3 speakers, please do post them in the Q&A function at the bottom of the screen. And as I said, we'll deal with all the questions at the very end. So without further ado, I'm going to hand over to our first speaker. First speaker is Gus McCarthy, former Managing Director of MKO Planning Consultants. So over to you, Gus.
Thank you, Jamie and Magda. I'll see if I can share my screen here. Okay, thank you, Jamie and Magda. As Jamie said, my name is Gus McCarthy. My background is in planning. Prior to establishing McCarthy Kevill O'Sullivan, or MKO, I had a planning practice, and prior to that, I worked in local government for a number of years. So I suppose I've been working in the area of development and infrastructure for my entire working life, and I've seen the evolution of sustainable development and the principles of sustainable development over a lengthy period from its infancy to the present day, when it's very much at the forefront of of progressing infrastructure and development. I suppose looking to for a moment at what is sustainable infrastructure all about. It's infrastructure that delivers positive economic and social impacts while ensuring environmental protection and resilience, and it meets current needs without compromising the ability of future generations to meet their own needs. You'll all have heard that definition of sustainable development. I suppose what's unusual is the fact that it has survived from the very beginning, from when I first heard about the term sustainable development. That term has been, it hasn't changed, and sustainable development includes not just the physical structure, but also the entire life cycle, from the planning and design to operation and decommissioning. Again, at the very beginning of my working career, these considerations didn't really come into effect in looking at projects and consenting projects through the planning process. Just looking for a moment at why we would advance, or why one would advance sustainable infrastructure. First and foremost, there are global and national goals, which again you'll all be familiar with. There's UN Sustainable Development Goals, there's the Paris Climate Agreement, and then there are further goals that flow from those, and obviously we have our own national targets as well. But the 3, I suppose, headings that always come to the fore when we're talking about sustainable development are economic social and environmental benefits. Obviously, the economic benefits leads to better value for money and long-term cost savings. The social element certainly wasn't there in the early stages in terms of social inclusion, proven quality of life. And finally, environmental benefits. This is the area that I will be concentrating on mainly because it's the area that I've worked in and that I'm most familiar with. Protecting the environment, reducing emissions, and building climate resilience. So that's, I suppose, that's the rationale for advancing sustainable development. The next question is the how, and I suppose the in the past, the approach to sustainable development, and indeed to some extent in the present moment, isn't at a strategic level, and that's what has to change, and that's probably what is changing. That's as we speak. It has to be introduced at strategic planning level. There's a role for innovative technologies. You have sustainable design and construction. You have effective management, funding on the, again, going back to the economic aspect of sustainable development, and finally policy and governance. And that's very much tied in with the first point there on strategic planning. The sectors that come to mind when we think about sustainable development are these five that I've on screen here: energy, buildings and materials, water, transport, and waste management. There are others, but I suppose these are the primary sectors that we we're aware of and we consider on a day-to-day basis in terms of sustainable infrastructure. Looking initially at energy, renewable energy projects, this is an area where we have made significant progress. But if you compare us with the rest of Europe and the EU, we're pretty low down on the scale. We've reached approximately 40% of our electricity needs from renewable energy. But we haven't made that level of progress in other areas of energy, particularly in space heating and transport. We have a long way to go. So when it comes to overall energy usage, we're down at about 15% coming from renewable energy sources. The other aspect of sustainable development under the heading of energy is smart grid. We have developed that to some degree using digital technology to improve efficiency, manage demand, and integrate renewable energy sources. Integrating renewable energy into the grid is a lot more complex than I think people are aware of, and it's the model that was used to do that in the first instance about 20 years ago, I think, was developed in the university and then put into practice by EirGrid. So we have made some progress, certainly in the area of renewable energy and on the grid front. Buildings and materials, some of those that are tuned into this webinar will be more familiar with this area than I am. So we're looking at green buildings, sustainable materials, and building information modeling. Water, in the area of water and sustainable infrastructure, we're talking about rainwater harvesting. We have made some progress, albeit limited, in that area. Wastewater recycling, that is happening, and I suppose when I started working in planning, both foul wastewater and what we call surface or stormwater were both collected in separate networks, and disposed of separately. And of course, that created its own difficulty because you were replacing nature where rain falls over an area, and the impact of storm water is spread over that area, collecting rainwater and bringing it to a limited number of locations created two problems. One was it created flooding in those areas where it was being discharged, and obviously in times of low rainfall, it created the opposite, drought in other areas. Nature-based systems, we're beginning to see some of these. Interestingly, Eoghan recently published a draft proposal for dealing with smaller settlements, small towns and villages that don't have municipal wastewater treatment systems. And they're proposing a nature-based system, albeit that we're talking about relatively small scale, but a move away from the conventional type of, shall we say, treatment to nature-based treatment systems. An area that I think everybody is familiar with is the area of transport and efficient public transportation. This is a topic of conversation and a media topic in Ireland on a daily basis, and one where we have a long way to go in terms of public transportation. Ireland is largely dependent on private cars, as we know. There's quite a difference then between urban and rural, particularly in the area of transport. Electrified infrastructure, we have very little of it. I believe there's considerable progress has been made on designing the electrification of the Cork to Dublin railway line, and the expectation is that that will be rolled out in the short to medium term. So we are going to see some, I suppose, electrification of public transport. Waste management. Over my working life, a lot has changed in this area. Everything went to landfill not that long ago. We have diverted waste away from landfill to a large degree. We have recycling, reuse, an element of reuse. We still export waste, of course, for to be incinerated abroad, which isn't sustainable in the long term. And we also have the other area is the use of recycled materials in infrastructure projects. Again, very much in its infancy. In my experience, some of you may be more familiar with this. I've seen some examples, but quite limited. So I suppose looking for a moment at the background to this sustainable development and sustainable infrastructure and where it came from. And the first that I heard of this was the Brundtland Report of 1987, and that's where the definition of sustainable development that I mentioned earlier, that's where it came from, and it hasn't changed to this day. And I suppose at that stage, this report was published, but nothing much happened immediately thereafter. And then over a period of time, a number of developments took place, most notably the EU influence, the EIA and the Habitats directives in 1995 1985 and 1992 respectively. And you could also add in the Water Framework Directive, which dealt with the water quality and water bodies. These had mandatory requirements that began to, I suppose, introduce or sustainability into our decision-making process. Another development was the establishment of the EPA in 1992. We had a national sustainable development strategy in 1997, which was, to me at the time, it was very forward. I thought as a document that was very forward thinking, because it put into a single document areas that I suppose the planning process had been working in for years, and it set it up. It gave a purpose and a reason and a rationale for why we were making some of the decisions we were making, because prior to that there was a tendency for, I suppose, decisions in the planning system to be seen very much as biased or ad hoc or whatever. This gave a structure and a foundation to the approach that was taken in planning. We then had, after I suppose a boom in the period in the late 90s that went into the early 2000s, we had the National Spatial Strategy, and this was the first time that there was an acceptance that it's not, that we need to move away from silos and sectoral approaches. We'd had national economic strategies prior to that, but they didn't have any spatial dimension. So the first national spatial strategy was published in 2002. Now, it didn't achieve great success because there was significant, I suppose, political input into the document, and it was to be driven then by the decentralization of government departments out of Dublin into various towns throughout the country. But I suppose the rationale for the National Spatial Strategy was to ensure that there was population distribution and to take the pressure off the East region. Sorry, more even population distribution. The Planning and Development Act 2000 was the very first time that the concept of sustainable development it became part of our legislation. So that piece of legislation is quite significant when we're talking about sustainable development. The key drivers then, and these are terms that didn't exist 35, 40 years ago to a large degree, and certainly not in the world that I worked in. The idea of carbon footprint, climate change, biodiversity, and more recently, I suppose, nature restoration is the one that's coming to the fore. Because obviously there's an appreciation now that we've lost an enormous amount of our biodiversity, and we're in crisis mode in that regard. So as I said, these are some of the drivers and some of the terms that are used on a daily basis, and indeed they are the new legislation in the area of sustainable development and biodiversity and environmental the environmental aspect of sustainable development. So I suppose what's happening in that space at the present moment, there's significant new developments, and now again, as I said earlier, I'm focusing on the environmental as opposed to the social and economic aspect of sustainable infrastructure. You have the nature restoration law, and this is coming from Europe. There's a mandatory requirement on Ireland to produce a national nature restoration plan. The National Parks and Wildlife Service are currently working on this. They had 2 years from 2024, so there's a year gone. So they have roughly a year left to produce a national nature restoration plan, and that includes a wide range of measures for nature restoration. There's a requirement for example, obviously Annex 1 habitats have to be protected. There's a requirement for 10% open space or green space in urban areas. There's a requirement relating to wild birds in rural areas. So it's both urban and rural, and there's requirements in relation to pollinators, which again you'll have seen some documents being produced at local level in that regard. So that's a significant piece of new legislation. The other then is the National Biodiversity Action Plan, and this has already kicked in from a statutory point of view. There's an amendment to the Wildlife Act which requires public authorities to have regard to and to report annually on biodiversity, and that's happening as we speak, and that's a significant, I suppose, move forward in terms of recognizing the importance of biodiversity. And the third area then is in development plans. There are mandatory requirements for biodiversity and nature restoration to be included now into development plans. Up until now, plans made reference and to the protection of what we call European sites, Natura 2000 sites, but didn't, while they would have made general reference to areas outside of the Natura 2000 sites, there wouldn't be specific areas identified and specific requirements, mandatory requirements in terms of biodiversity and nature restoration. So that is a significant development. Where is all of this going in the future? I suppose you have the mandatory and the non-mandatory, and the non-mandatory is becoming quite significant. So initially at mandatory level, the approach now is to incorporate sustainable development principles and biodiversity requirements and nature restoration requirements at plan versus at project level. And early intervention at strategic level rather than at project level is all tied in with this. For example, in a number of European countries who are developing offshore wind, not alone did they identify areas offshore that were suitable or deemed suitable for wind energy, as we do in Ireland, but they had assessed these areas from a sustainability perspective prior to designating them. Now, the same thing is happening in Ireland. That approach is being followed. So up until now, sustainability was at a project level. And I suppose if we look at the state of our environment, again, looking at it from an environmental perspective, we didn't achieve what we set out to achieve doing things on a project by project basis. The other thing it has led to is significant conflict and a lot of legal battles on projects because they are deemed to be in conflict with the principles of sustainable development and in conflict with the environment. So the thinking now is that you build in the sustainable development into the plan and into the designation of areas for whatever it is, whether it's housing, wind energy, or indeed any other development. So you've already considered and surveyed the areas for their suitability, or assessed them, for their suitability in advance of designating them, rather than leaving it to the individual project that comes after the plan is adopted. Similarly with mitigation, right now mitigation is done at a project level, and that's quite piecemeal. Ultimately, the mitigation hasn't resulted in restoration of nature, or it hasn't increased biodiversity, because it's, as I said, it's too piecemeal. Whereas if this is done at a higher strategic level, at plan level, then it should result in a different outcome. The non-mandatory area is becoming quite significant, and is probably one that isn't well known. So private enterprise are funding nature restoration projects now to offset impacts. MKO are currently working on a number of nature restoration projects in Ireland to offset the impact of particularly data centers. And this is largely, not entirely, but largely driven by the data center world, to offset their impacts, not just in Ireland, but abroad. So, for example, areas of river banks are being identified that have been obviously changed over time, and agreement is reached with the landowners that certain works are carried out along that stretch of river, and it comes under the control of this management regime for a period of 15 years, and effectively you're restoring the river channel to what it was before it was, shall we say, prior to human influence, or prior to more recent alterations. Broadly, what has happened in streams and rivers is that they've been cleaned up to drain the adjacent lands, and natural weirs and so on have been removed, and the result is that the level of biodiversity in those streams is minimal. So there's quite a lot of that happening. We've also seen financial capital following sustainability. So those companies who are in a position to raise funding on the basis of their sustainability record are able to raise money at a cheaper rate. And this is actually happening even in Ireland in the housing sector. We're working for a number of companies at the moment who look at biodiversity on the lands in the first instance, before they even put pen to paper in terms of preparing a planning application. The first thing they look at is they see biodiversity not necessarily as a constraint, but as an opportunity. Now, of course, the project has to stack up. It has to be viable. So there is significant movement in the area of biodiversity net gain outside of mandatory requirements, and I think this is an area that we're going to see, growing significantly, and we're going to see significant funding going into this area. We don't yet have a regulatory environment. In other words, who measures this work? This is done abroad. We've looked very closely at examples in Europe and in the US. Believe it or not, the US is have made they've been involved in nature restoration for quite some time, and there's a lot to be learned from what they've done. But ultimately, we will need a regulatory framework around that, so that the projects are vetted in some way, and to ensure that the work continues over the period of time that's identified. So if an area is going to be, if it's a riverbank that's going to be restored, that first and foremost, it needed restoration. Secondly, the work is done to the required specification. And finally, that area is maintained in its restored state into the future. But that will come. I wouldn't have any concerns that will come. So I suppose that's what's likely to happen in the future. You have the mandatory requirements and the as I said, the non-mandatory. That is the end of my presentation. Thank you very much for listening.
Brilliant. Thanks a million, Gus. That's a great overview of sustainable infrastructure, covering broad range, renewable energy, buildings, water, wastewater, transport, waste management, and looking at the past, the current, and the future. What's happening there. So I'm sure lots of people with questions there. So if you have any questions for Gus, please put them into the Q&A function at the bottom of the screen, and we'll deal with all the questions at the very end. Okay, so without further ado, I'm on to our second presenter, so Maryann Harris, who's Environmental Planning Manager with Department of Housing, Local Government and Heritage. So Gus talked about biodiverse rich and biodiversity net gain, and Maryann is going to try and handle the question of how to make communities more climate resilient and biodiverse rich. So over to you, Maryann.
Thanks, Jamie. I'll just get my presentation up there now for you. Okay. I hope that's okay and you can see that.
Perfect.
Okay.
Perfect.
So the topic I'm speaking about is how to make communities more climate resilient and biodiverse rich. So just, I don't know, can you see the toolbar there? Is that in your way? Okay, it's gone. So just, I've given you a little bit about my background there. I'm not going to read it all out to you, but I've 25 years experience in government, and I've worked mainly in the area of biodiversity and climate. I'm a landscape architect and an ecologist. And I worked previously in local councils and also the Dublin Carrow on climate action. So the unit I work in now in the department, we lead on the development, implementation and guidance for EU directives for the planning system in Ireland. So that includes some of the ones that were just mentioned there, the EIA and SEA directives in particular. And we also work with other departments, particularly in relation to the EU directives and regulations insofar as they impact on the planning system, and provide technical advice and represent the department and indeed Ireland at some levels of the Commission. So one of the things that I have found through my career is the increasing influence of environmental assessment on planning. So as we move forward to how biodiversity and climate will influence community planning, this is becoming a key issue. And EU laws are there to ensure that all the member states will assess the likely and significant environmental effects of certain types of infrastructure projects and then public plans and programs. And they're kind of, the way the effects are assessed would include different themes, and key to those themes include the effects on biodiversity and climate both. Gus had just given you a background there of some of the earlier stages of the EU legislation, and it's important to look at all of them in the round as kind of tools for assessment. And these include Strategic Environmental Assessment Directive, which I work a lot in that area because I work on like national plans and programs, that sort of level. But also the EIA directive, the Habitats Directive, which is also aligned with the Birds Directive, Water Framework Directive, and the Floods Directive. So all of these have their own different parameters for considerations of environmental effects. And for SEA, the Commission would refer to SEA as the lead directive. So that would be an overarching type of approach at the plan level. And for example, the EIA directive, was revised by the European Union in 2014 to add to it more consideration on biodiversity and climate as policy had advanced. So you can see how much biodiversity and climate are coming to the fore on these legislative frameworks that filter down across the EU. And then if we look at the SEA directive and its whole purpose, and every EU directive, the purpose of it is always in Article 1. So for the SEA directive, it's all about promoting sustainable development. And increasingly, we can think of it in terms of how it can help us to promote the UN Sustainable Development Goals, how that process of assessment can examine each sector and see how can we further sustainable development. So that can also help us tie in with United Nations policy. But getting back home to an Irish context, if we look again at where the planning for new communities is going to be changing and what is happening, one of the key changes has been the amendment to the Climate Action and Low Carbon Development Act. So the original act in 2015 was amended in 2021, and that gave us the National Climate Objective, which goes back to the title of this talk about climate resilience and biodiversity-rich communities, and gives us a target by no later than 2050. That national climate objective has to permeate through all kinds of government policy and plans. And then you also have under the National Climate Action Plan, you have a requirement for an annual update of the plan to see the progress, but also each sector. So our department, like all the others, has to answer for different objectives in that. And then you also have increasingly the alignment with the planning system through development plans at the county and city level, having to align with local authority climate action plans. And I would have worked on the first ones of those in the Dublin region and Dublin city. And then with the CARO, we would have worked on monitoring the implementation for those local authorities of those climate action plans. So there has to be this increasing alignment, and they all have now a statutory basis, which up until recently wasn't the case. Just looking at my own department in the last 2 years, some kind of approach that has been taken to all the new policies and strategies that would affect planning at the community level for biodiversity and climate. The National Biodiversity Action Plan, which is in place, this current revision is in place till 2030. So that aligns with other targets for 2030, and that is now legally binding under the amendment to the Wildlife Act in 2023. So that's binding on the planning system and all plans made underneath it. Whereas it wasn't previously. Previously, when I was working at the local authority managing biodiversity, we had to produce biodiversity action plans for the local authorities and then try to make those in some way binding by having objectives in the development plan. But now it's automatic. The Sustainable Residential Development and Complex Settlement Guidelines that were produced in 2024 are national policy, and they also bring in alignment on things like climate resilience and also environment in placemaking. The National Planning Framework first revision to 2030 was just completed this year, and that has also changed direction in terms of policy and strategy of biodiversity and climate. We also have the National Strategy for World Heritage Sites, which has just been launched, and that gives new guidelines that'll be proposed, including ones on how to make management plans for them and how to carry out environmental assessment of cultural heritage and landscapes. So I think that's a really interesting one because it's linking biodiversity and cultural heritage, and World Heritage Sites can be designated for those considerations in their own right. So the Nature Restoration Plan, which will be a national plan as well by our department, is currently being prepared by the NPWS, the National Parks and Wildlife Service, and that will include alignment for new national policies. It will be at EU level, so it will actually involve being submitted to the European Commission for any comment and for a review by the European Commission. So then that will come back to Ireland, and there may be, again, further revisions. We don't know, but that's a 6-month process after we draft it and consult on it nationally. And then we have the National Biodiversity Action Plan. Legally binding status of that means that the Nature Restoration Plan also will have certain legal parameters for things like development plans, and it will influence all kinds of plans and programs in our department and probably in other departments as well. So that's quite a lot of strategy that's happening in the last just 2 years. I have been working on the National Planning Framework and managing the environment assessments for that. The whole purpose of that is to promote sustainable development, and it's enshrined under the Planning Act 2000 that it should be at least revised, replaced, or retained every 6 years. that will be moving in the next cycle under the Planning Act of 2024 to a longer duration. And so will the county and city development plans. But as it stands, we've had a hierarchy in place since 2016 of our planning system, and that gives a national direction and then a regional focus, and then the local authority specifics. So we also have to bring in more alignment of our environmental assessments, and this was discussed by an expert group report published in 2023. So with the revision process that we've just completed for the National Planning Framework, we have also reviewed the strategic environmental assessment and the monitoring, and whatever comes out of that has to inform lower tier plans. So we've been very cognizant of trying to set a national best practice that could then be adapted for regional and local particular situations. In terms of the changes that have emerged in terms of the National Planning Framework, we've had those changes in policies, legislation, climate and data on climate, and our understanding of our position in terms of where we are for meeting our climate targets and what specific areas we fall short on that are critical, and what might be under critical infrastructure need to be considered. And then also in terms of our knowledge on biodiversity, there was, since the 2018 NPF, there was a review by National Parks and Wildlife Service and reporting to the European Commission on monitoring of biodiversity, which showed 80% of habitats in Ireland are deteriorating. We've also had demands for housing and an increase in the population, which is way beyond what is the EU average and will continue. And we've also had changes in work patterns due to COVID and working from home, remote working. And we've also had differing changes to health policy, particularly again with the influence of COVID. So the new National Planning Framework contains what are called national policy objectives, as did the previous, but the new ones, there are a significant amount of new ones on biodiversity and climate in it, and they cover all different levels of biodiversity in terms of ecosystems down to species and consideration of those, and the requirement to align now with the new NBAP and the NCAP. So there's stronger links now in the National Planning Framework between utilising local biodiversity action plans and incorporating that into planning at the county city development plan level. There's a new SEA monitoring program, which I'll talk about in a moment, which includes indicators for biodiversity and climate. And there's also a proposed new national ministerial guidance on biodiversity and planning to issue. There are also new NPOs to address coastal management, particularly, again, critical infrastructure. So the SEA monitoring piece that has been done for the National Planning Framework under the SEA process, in general, SEA monitoring is about to foresee environmental effects. So you're examining different alternatives, and you're trying to figure out what may happen and how to choose the best approach. So it's entirely predictive exercise. So when you're doing your plan, it is predictive. So the point of the monitoring is to provide some verification process and to test if what you had planned for will actually work as you had planned it to work. If not, you have to consider taking remedial action. And they're really about ensuring sustainable development. So we can look at this as a control process, which again is aligned with the SDGs. So in the reports, which you can see online, we have the SEA monitoring program format, which has been revised as well to include the topics. So I mentioned there's different topics under the legislation. Biodiversity is one of the main topics of the SEA directive. And then we have specific indicators, and for each of those, we have a target set and a threshold to be identified and acted on. And then we have potential remedial actions that could be taken, although those could, change depending on the monitoring outcome. And then we have identified a data source and the frequency that the data is released and who it's monitored by. This is to make sure that all of the indicators have measurable baseline attached to them and can be verified and measured. Because sometimes with plans, there have been indicators written into them that when people go to actually do the monitoring, they find you can't actually get data to measure that, or what does it actually tell you regarding that particular plan and how it's meeting its targets? Is it very informative, or is it too general, or what is it telling you? So we did an extensive review with quite a degree of consultation, including targeted stakeholder consultation on this and workshops. So the changes that have arisen since the 2018 version, we've moved from 9 to 25 indicators. So you can see there's a lot more monitoring going to be happening. Only one indicator was even retained from the original NPF. And this is again about road testing the feasibility of some of them. The indicators that were included, which were in the draft and which were then unchanged post-consultation, were 15. So then after the post-consultation, there were 6 that were revised and 3 that were new. So the consultation process was really useful. And different data holders also gave comment on what could be used to try to get the best possible baseline to be used and the most appropriate indicators for this particular plan. So it's quite an involved thing. The Sustainable Residential Development and Compact Settlements guidelines were issued in 2024. They are also going to have a massive influence on how planning for communities will happen, because as I mentioned, we have to plan for significant population growth, and that will include developing new developments for housing and also looking at brownfield sites and redeveloping those. And this will give greater flexibility in residential design standards. We have moved towards compact growth to address climate change issues, and an increased focus on access to transport, again, to try to reduce the emissions from the sector, and how communities are planned to try to make them more carbon neutral. We also have brought in new public open space standards with increased measures for environmental protection. So in particular, there's an emphasis on planning for strategic green and blue infrastructure. So this is to ensure that open spaces are designed and that they have a purpose, and they support connectivity of habitats and sustainable recreation, rather than a developer-led approach, or the idea that open spaces are the leftover spaces you can't build on kind of thing. We've also, a significant change has been that protected areas for nature conservation cannot be considered to be in part of any calculations for recreation and amenity or open space. So, in the previous decades, there was a reliance on coastal areas as recreational zones, but, many of those are actually designated at the highest level at EU level. So this has removed that possibility, and it doesn't mean you can't enjoy those areas, but for development purposes and planning purposes, those cannot be considered to be amenity zones. They have to be considered to be prioritized for nature. SEA monitoring in that also includes to measure if counties have prepared such GI strategies. And the consideration of nature restoration is in it, not just conservation of biodiversity, but actually the concept to pave the way for restoring it. And this is to align it with the forthcoming National Restoration Plan, which will be prepared under that EU regulation, the Nature Restoration Law. And it will require local authorities under their development plans to support its implementation. It brings a more ecosystem-based approach to protecting biodiversity. Previously, as we mentioned, some of the other legislation focused on habitats and species. The Water Framework Directive would be more ecosystem-based as well, but a lot of the protection of biodiversity has been very much habitat and species level. This is at ecosystem level. There are quantum targets for urban ecosystems, particularly for urban tree canopy cover and green spaces. There's also measures for restoring free-flowing rivers. So that could end up trying to convert grey infrastructure to green infrastructure along riverbanks. And there's links to soil protection and limiting land take, which pave the way for the forthcoming EU soil monitoring directive, which may be happening. In terms of future work, we will see further need for alignment of objectives and plans. We will also see a need to target resources based on urgency of actions. So what I mean by that is, while it would be great to restore nature everywhere, we're going to have to focus on the monitoring and baseline data and what it's telling us about which species and which habitats and ecosystems need more urgency of approach. There'll be greater emphasis on monitoring of outcomes and the need to change course if needed. So as I've said to you there's a lot more indicators to monitor at the national level that will also filter all the way down through regional and local levels of plan making. The need for supporting protected areas through connectivity. So the idea that you just looked at protected areas in some sort of isolation is changing, and the nature restoration plan will certainly be including protection of habitats and species outside of red-lined Natura sites or European sites. There's also going to be increased focus on protection of vulnerable ecosystems from climate change. So what I mean by that is if you look at the NPF and the Climate Action Plan, there's a consideration given more to future changes that could happen due to sea level rise and also coastal squeeze, where you have particular types of ecosystems and particular types of habitats that are very vulnerable to loss, permanent loss. So how to defend those or even enlarge other areas and restore other areas to supplement that. We'll be looking at things at the ecosystem level, and that will tie in with the emphasis on environmental assessment at the plan level rather than simply the project focus. And I think that ties in nicely with the previous speaker's point about trying to make a difference at the project level as opposed to having a plan that sets out at a higher level what's expected and to avoid a piecemeal approach. There's also increasingly an emphasis on SEA as a process rather than EIA to identify what needs to be done and to set out the baseline that's to be used. And a big part of getting all of this planning successfully over the line will be to have strong baseline data that we can rely upon and measure against, so that as we move to 2030 and 2040, 2050 targets under all of these plans, that we can determine what we've achieved and how far we need to act further. The baseline for the National Restoration Plan is 2018. That's under the EU law, but it's interesting because it also ties with the year of the first National Planning Framework, 2018, which we're also monitoring against till 2040, as I mentioned. So 2018, if you remember, if you can keep that in your mind, is kind of baseline or ground zero, and what we do from then and how we perform will be critical. So I'll just stop sharing my screen there.
Brilliant. Thanks a million, Maryann. That's very thorough go through in terms of the different directives, laws, frameworks, strategies, and so on. So there's so much there. So it's really useful to have all that kind of put together and kind of to show it in its whole. Obviously very challenging for people in the area now to be working because there's so many different things that they have to consider. And we might bring up some of that in the Q&A afterwards. So we're going to go on to our third speakers. So our third speaker is Professor Eoghan Clifford, who's Professor of Engineering, the head of the discipline of Civil Engineering at the University of Galway, and he's going to focus on wastewater treatment systems and as part of our sustainable infrastructure. So over to you, Eoghan.
Hi, everyone. Hope you can see the presentation slides.
Perfect.
Yeah, okay, great. Hi, everyone. So I'm just going to give talk today about sustainable infrastructure in the area of wastewater and just talk about a few case studies where we were looking at what the issues are around sustainability, particularly in relation to process emissions from wastewater treatment and also embodied carbon of that infrastructure and how we might go forward with making that more efficient. Sorry, no, it's not moving forward. So I'm just going to give, as a bit of background, a couple of slides were given to me by Eoghan in relation to a recent Engineers Ireland talk. And I suppose just to give you context as to their point of view in terms of where we need to go for sustainability in wastewater treatment. So basically, they are aiming for net zero by 2040, which I think will be very challenging. And at the end of this year, they hope to produce their process emissions strategy. And we'll see in a few minutes that process emissions are going to be one of the key challenges and areas where they are going to have to focus in relation to their infrastructure. So some of the key I suppose, areas they're going to have to look at is trying to meet 40% energy demand by 2035 for their wastewater and water treatment infrastructure from renewables. The objective is to have treatment plants above 10,000 population equivalent, energy neutral by 2040. For smaller plants, that will be extremely challenging. And of course, in an Irish context, most of our treatment plants, the vast majority of our treatment plants are smaller than 10,000 PE. But of course, the ones that are larger will use more energy. Currently, aside from the example I'm going to give you, there is no long-term monitoring of process emissions in wastewater infrastructure at the moment, albeit they do hope to have monitoring in place in Ringsend by 2027. And I suppose from their point of view, when Irish Uisce Éireann have already done some analysis as to their overall emissions across the water and wastewater infrastructure, including their scope 1, 2, and 3 emissions. So scope 1 emissions will be direct emissions from the infrastructure itself. Scope 2 might be things like electricity usage, etc. And scope 3 are things like procurement, some aspects of travel and transport, etc. So I think what's important to look at here is if you go to their scope 1 emissions, then what they call process and fugitive emissions, so things like nitrous oxide, methane, less so carbon dioxide because it doesn't have to be counted at the moment for various reasons, are by far the biggest proportion of their scope 1, so direct emissions from their infrastructure. And for scope 2, a lot of it stems from electricity consumption in both water and wastewater treatment plants. And a lot of the work we're doing is focusing on these areas. So that's kind of a bit of a background. Today I'm just going to talk about 3 case studies. So the first one is an embodied carbon analysis we did at an Irish wastewater treatment plant that was upgraded relatively recently. The second one is in relation to aeration technology, a case study we were involved in with some Irish companies where we looked at the relative emissions from the upgrade of aeration systems in wastewater infrastructure versus their actual operation. And the final one, very briefly, will be around the area of process emissions. And again, be talking about an Irish case study that we're doing with Wardenburg at the moment in Enniscorthy in County Wexford. So to move on to the embodied carbon and operational carbon. So as people might know, obviously there's two main sides, I suppose, to impacts and carbon impacts when it comes to wastewater or any type of infrastructure. And you have the embodied carbon due to construction, use of materials, etc. And then obviously the infrastructure itself is operated across a lifespan, 20, 25, 50, 100 years, whatever that might be. So I suppose part of our work has been to look at what are the relative, to what extent does each of these impact the emissions from the infrastructure itself, and where should the focus be in order to make that infrastructure more efficient. So one of our recent pieces of work was to look at an upgrade of a 4,500 population equivalent wastewater treatment plant. You can kind of see here in the photo just an overview of the treatment facility itself and some of the various components. So our study looked at the construction of a primary and secondary clarifier, the aeration tank, the control building, and the aeration equipment. So we would have drawn from bill of materials from drawings provided by the contractors and also from other information from the contractors. Where possible, we also tried to model the plant use during construction, again with data from the contractors. There were some limitations as to what we could model there. And finally, we looked at electricity consumption at the treatment plant, but we only looked at aeration across the 50 life span of the treatment plant. Aeration we would expect in this particular treatment plant to be about 60 to 70% of the total electricity consumption in that period. So there's a lot kind of in this slide, and I think what I'm going to focus on today are the global warming potential, so basically the carbon dioxide equivalent emissions, but we also, as part of these studies, look at other impacts from eutrophication, freshwater toxicity, water use, resource use, etc., that these projects might entail. So the key part in this particular treatment plant, but I think there are lessons to draw for other treatment plants, was when it came to the overall carbon contribution, the aeration tank was the key contributor. And you'll see that in blue here. Note the y-axis starts at 75%. So the aeration tank is over 90% of the total emissions. However, the actual construction, the embodied carbon, are a relatively small part of the overall emissions in this particular plant. It's expected that if the electricity consumption is as predicted, that over 90% of emissions will be due to electricity consumption, and most of those associated with the aeration equipment. And if we had considered process emissions in this plant, we don't have any data for it in this plant, then we would expect the actual construction, the embodied carbon, the embodied impacts to be far lower per meter cube treated than the operational impacts. So the key thing that came out of this particular project was, when it comes to this type of infrastructure, the actual embodied carbon impacts and the embodied impacts across other areas are likely to be small relative to the operational ones, unless, of course, there is action taken to make the operation of these systems more efficient. So focusing in on the aeration technology itself, and the reason I'm specifically focusing in on aeration technology, because it plays a key role both in the energy consumption in wastewater treatment plants, but as we'll see later on, in the actual process emissions that stem from those treatment plants. And as part of a project, we were involved with a company, Vortec. We were retrofitting a 200,000 population equivalent wastewater treatment plant in the UK. And during the tendering process, we were required to provide an analysis of the embodied carbon of the technology itself. And I suppose, separately and in parallel, we were asking whether an analysis of the operational carbon would be required. And we were told at that stage that it wouldn't, because it wasn't considered to be very significant. So we carried out our analysis for the embodied carbon, but we also looked at the expected operational carbon from the facility or from the aeration equipment itself. Obviously, a lot of that is stemming from electricity consumption and depends on projections as to how decarbonized the electricity grid would be in the future. What this slide shows is that when we did that analysis, the operational carbon comprised almost all of the carbon impacts, and in fact all of the life cycle analysis impacts that we measured across the aeration upgrades life cycle. And yet, in any of the projects that we're involved in, it is the embodied carbon which is what you are having to report, where it is required at all for tendering processes, but the operation carbon is not really looked at. But basically, the embodied carbon here would be far less than 1% of the total carbon emissions. So one of the key things is the electricity mix is a key input variable. So as you decarbonize the grid, of course, a lot of this can decrease. And the other key issue is the efficiency of aeration technology, which has a huge impact on how efficient your overall project is going to be across its life cycle. And one of the big gaps that happens with wastewater infrastructure is that in many cases, historically, aeration equipment has been designed based on clean water testing standards. However, its actual operation in wastewater can be very different to how it operates in clean water. And so I think for improving the overall carbon situation here, we need to actually look at the operation of technology in existing sites and use that to estimate what it will be in new sites or in upgrades. And sorry, I've just basically covered that there, but I think this is a significant gap in the wastewater infrastructure when it comes to tendering and installing various technology, is the embodied carbon of that technology can be very small compared to the operational carbon. And we need to try and develop better ways of standardizing and measuring what the operational carbon life cycle is going to be like in these systems. So the last area, and again, I'm skimming over these quite briefly, is in the area of process emissions, which again will be a key challenge for utilities going forward, both as part of their existing climate change targets, but also as part of the recast Urban Wastewater Treatment Directive, which puts more emphasis on nitrogen removal in large wastewater treatment plants, which it will have a direct impact on process emissions. So the process emissions I'm focusing here are nitrous oxide emissions, and they are expected to be the majority of all emissions in water utilities by 2030. Sorry, nitrous oxide and methane are expected to be the majority of emissions in many water utilities by 2030. It's likely nitrous oxide will be the more significant of those two because it basically derives from nitrification and denitrification processes, so the removal of nitrogen in the wastewater treatment process. So there has been some work done in this area over the last 10 or 15 years with a lot of key work in Finland, Denmark, and Switzerland, most recently in Netherlands, but also across other countries as well, albeit there are limited examples of long-term mitigation projects and limited examples where these are applied to wastewater treatment plants that are significantly impacted by storm events. And that obviously is the case in Ireland, and that has a significant impact on treatment operation and control. And for anyone who's interested, there are some useful links I've just left here. If people are working in this area and are useful in following up on some of the more recent work by utilities in the area of greenhouse gas emissions from wastewater treatment plants. Our particular project is in Enniscorthy, and there are two particular ways that can be used to measure emissions from wastewater treatment plants, direct emissions. And these are using what are called off-gas measurement systems, which basically collect the gases that are flowing off the treatment tanks from a portion or from all of the treatment tank and measure both the volume and the concentration of different gases in that gas mix. In most treatment plants, that is quite difficult because obviously they're open to the atmosphere, and so you end up doing it over a small area of the treatment tank and extrapolating from that. In some countries, such as Finland, where a lot of their infrastructure for larger treatment plants is underground, they're able to capture all the emissions from the infrastructure and measure them as they move out from the treatment facility itself. The other way you can do it is using probes. Anyone who works in the wastewater area or water area will be familiar with these types of in-water sensors. And with newer technology, we can now use in-water sensors to measure nitrous oxide in water itself, and from that we calculate what the emissions are likely to be based on information we have about the operation of the aerators itself. The relative trade-offs are that the off-gas measurement systems are more expensive but provide a direct measurement, whereas the aqueous monitoring systems are cheaper, provide somewhat of an indirect measurement, albeit ideally you would be able to use an off-gas system to calibrate the aqueous system, which might be deployed more widely. So our project currently in Enniscorthy comprises installation of these sensors plus a variety of other sensors that we are using to try and ascertain what are the reasons for the emissions, and also to try and develop better control processes which will reduce emissions in the treatment plant, but at the same time also reduce energy consumption while maintaining compliance. So we've installed a variety of different process sensors in Enniscorthy. And even the installation and maintenance and operation of these sensors are not without significant challenges, which shouldn't be underestimated in this environment. So just to give you a little flavor, and I put a big caveat on this. This is early indicative data, and I don't expect our final data to look the same, but just to, I suppose, give some initial numbers as to what we're seeing in that treatment plant. So typically emission rates are expressed in terms of the kilos of nitrous oxide emitted per kilo of total nitrogen influent to the treatment plant. And that aligns with how the IPCC, the International Panel for Climate Change, report emissions. And by doing it in that way, we may be able to use these emission factors across other treatment plants that may not have monitoring, but have a similar setup. So in this particular treatment plant, we found an emission rate of 0.0017 kilos nitrous oxide per kilo total nitrogen. This will be at the lower end of previously published ranges, but this is just analysis from August, and there are very significant seasonal variations that can occur in treatment plants or of orders of magnitude. They can vary between seasons. The majority of the emissions are during the aeration period, and there are aspects about how we control that aeration period that might allow us to better control those emissions. And also there are aspects about how we control denitrification periods that might allow us to destroy nitrous oxide as it's being accumulated in the treatment plant. If these emissions were to continue at this rate for a year, if we were to extrapolate them out, it would be equivalent to about 47 tons of carbon dioxide per annum from the biological reactors in Enniscorthy when measured as a 100-year global warming potential, which is typically how we express these. However, the caveat here is that I would say that this is likely to be at the lower end of final results, and our analysis will have completed 1 year of analysis in April and May of next year, and we will be able to issue a lot more detail at that stage as to what the actual emissions are like and how we might better control them. Okay, so some of the kind of lessons from this and the next steps will be, well, we won't be able to monitor emissions from all treatment plant infrastructure, and Eoghan have a plan to, I suppose, target the top 10 wastewater treatment plants that process the most nitrogen, and this would make sense because they would obviously have the most emissions. But for the other treatment plants, what we would hope to do is have enough case studies in larger treatment plants that we may be able to develop emission factors that can be applied to non-monitored treatment plants to allow better estimation and reporting of emissions. The other thing from this project that has been very useful is learning about how we actually monitor and or operate these sensors, how often we need to calibrate them in order to get accurate operational data, and knowing that we will get some inaccurate data, how do we backfill data or use data that we think might be inaccurate in any control algorithms. So the next steps will be on-site trial of new control approaches, and what we intend to do before that is de-risk those with some calibrated modeling by developing calibrated models of the treatment system, which we are currently doing, and trying out virtually some of these new control approaches before we actually implement them at the site itself to try and de-risk the outcomes. And so just to finish up, some of the key takeaway points, I think some of the challenges that we're encountering when looking at emissions in wastewater treatment plants is that the treatment plants haven't historically been designed to enable operational efficiency from the outset. So very simple things like the controllability of pumps and aerators in many treatment plants is limited. And if you can't control the systems, then of course it will be hard to actually mitigate both energy and emissions. So things like considering the sensors at the design stage and considering how and where they might be installed, how will you capture the data, and how will you actually use that data to control mechanical equipment on site. And also in relation to new urban wastewater treatment directive and some of the challenges that's going to pose, I think treatment plants are going to have to be designed to enable ease of upgrade in the future as new directives come downstream. So two other areas that I just mentioned is that while there is a focus on the emission side in this particular talk, what we've seen in other work is that by looking at the emissions, we learn a lot more about the process itself, and from that we can actually lower the costs of running the process. So we are able to do the two things at once. It is challenging, but it can be done, and that can actually enable improved treatment capacity within existing infrastructure while still maintaining the discharge limits. And as was mentioned at the beginning by Gus before, for smaller treatment plants, I do think nature-based solutions are going to be key in the future, albeit there is still work to be done to ensure that they meet required performance. And just to end, what I haven't been able to talk about here is the role of sludge and biomass in decarbonising wastewater infrastructure, but there is a lot of exciting and interesting work going on in that space as well. So thank you very much.
Brilliant, John. Thanks a lot. That's a good overview there. We really know the importance of being able to accurately monitor things because one thing is to plan, design, plan, build. We need to know, is it actually functioning well enough? We need to know what the actual emissions are or the performance are, and we can learn an awful lot from that and improve the infrastructure going forward. So we're just on the Q&A session.